Alright, this video is on 10-4, perimeters and areas of similar figures. Now, this is a relatively simple section here. If the scale factors of two similar figures is A over B. We've already dealt with scale factors. It's simply the ratio, it's basically the ratio of the sides, right? So, if the scale factor of two similar figures is A over B, then number one, the ratio of their perimeters is also A over B. This is also referred to as the perimeter ratio. Right, it's also referred to as the perimeter ratio. The perimeter ratio is the same thing as the scale factor or the similarity ratio. And then number two, the ratio of their areas is A squared over B squared. This is also called the area ratio. Alright, so you have your scale factor slash similarity ratio. Your perimeter ratio is the exact same thing. Your area ratio, you just take this one and square both the top and the bottom. Alright, let's look at a problem. Make sure you write this down in your notes and we're going to work on a problem. Alright, so say we have two trapezoids. We have that one. And then we have this bigger one. Alright? If this is 6 meters, this is 9 meters, and we already know these are similar. So what I want to find the similarity ratio. I want to find the perimeter ratio. And I want to find the area ratio. Alright, so I want to find all three ratios. Now, like I said, we already know they're similar, so the similarity ratio would simply be 6 over 9, which reduces down to 2 over 3. Alright, it'd be 6 over 9, which equals 2/3. So our similarity ratio for these two trapezoids is 2/3. Now remember, the perimeter ratio is the exact same thing as the similarity ratio. So that means our perimeter ratio is also 2/3. And now our area ratio is simply our perimeter or similarity, doesn't matter because they're the same thing. It's either our perimeter or our similarity ratio squared. So we're going to do 2/3 squared. So distribute this through. 2 squared is 4. 3 squared is 9. So that's our area ratio. And that's our perimeter ratio. Alright, let's look at another problem. Alright, so here we have a hexagon, and here we have a slightly bigger similar hexagon. That looks like poop. That didn't make anything better. Alright, so this is 4 centimeters. And the other one is 10 centimeters. Alright, so what I want you to do, find the similarity ratio, find the perimeter ratio, and find the area ratio. So pause the video, take a few seconds and figure this out. Alright, so your similarity ratio would be 4 over 10, which of course reduces down to 2 over 5. And remember, your similarity and your perimeter ratio are the exact same thing, so both of those are 2/5. And your area ratio is simply this one squared. So 2 squared is 4, 5 squared is 25. Hopefully you got those three values. Similarity ratio 2/5, perimeter ratio 2/5, area ratio 4/25. Now, let's actually use this to determine some information here. Alright, so we have two triangles. It's kind of light. Alright, so we have two triangles. We know that the area of this smaller one is 50 centimeters squared. The area of this bigger one is 98 centimeters squared. And I want to find the perimeter ratio. Alright, I want to find the perimeter ratio. But all I know is the area of this one's 50, the area of this one's 98. And I also know that they are similar. So, what are we going to do? Well, let's set the problem up. Let me erase that because I'm going to write it related. We know our area ratio, which is a squared over b squared, equals 50 over 98, which reduces down to 25 over 49. Alright? We know it reduces down to 25 over 49. Well, since a squared equals 5, to find our perimeter ratio, so when we go from the perimeter ratio to the area ratio, we square it. But to go back, we're going to be taking the square root. Alright? So the square root of 25 is 5. The square root of 49 is 7. Alright? So our perimeter ratio is 5 to 7. Meaning if this side, say this side had a side length of 5, this would have a side length of 7. This had a side length of 10, this would be 14. Alright? Because that's 5 to 7. And here, all I did was multiply by 2. Alright, so this has been your 10-4 perimeters and areas of similar figures video. Feel free to watch this as many times as you need to. Make sure you understand how to go between the different ratios. Remember, your similarity ratio, if it's A over B, your perimeter ratio is also A over B. And then to get to your area ratio from your perimeter ratio, you simply square it. So this would be A squared over B squared. Now to go back, if I give you your area ratio, remember that's A squared over B squared. To go to your perimeter ratio, you're going to take the square root of your area ratio, and that's how you're going to come up with A over B. And of course, this also equals the similarity ratio as well. So make sure you know how to convert between these. Now, you can also use these to set up proportions. So if I say the area ratio is 4 to 9, and the area of the larger, like look, here we go. If I say your area ratio is 4 over 9, and the area of your larger figure is 81, well, you could simply here set up a proportion. 4 over 9 equals x over 81, and you could actually solve that proportion and get the area of the smaller figure. Alright? So, we'll work on some more problems tomorrow in class. Watch this video as many times as you need to. See you tomorrow.